Hello everyone. Today we are going to start our series of lectures on chapter 2 of our syllabus. Now our syllabus begins from chapter 2.2, which is on quadratic functions. Now we probably know some basics about quadratic functions. However, here we are going to go into some more detail about quadratic functions, the different forms, the graphs, and how to extract some critical information from the different forms of the quadratic function and be able to draw a fairly accurate graph. Now let's quickly go over the topics that we are going to cover on quadratic functions. We're going to go over the properties of parabolas. A parabola is the name given to the graph of a quadratic function. A parabola has a U shape. All right, all quadratic functions have a U-shaped graph. It could be an upturned U or a downturned U, and that particular shape of the graph is, and that particular graph is called a parabola. All right, so we are going to go over the properties or characteristics of parabolas. Then we are going to learn how to graph parabolas with a set of information that we can extract from the given function or the form of a quadratic function. And then we are going to talk about a quadratic function's minimum or maximum value. And then we'll go into solving some problems utilizing the minimum or maximum value. The minimum and maximum value of a parabola can give us a lot of information about the function, especially in situations of real life applications. Okay, we are going to start our study of quadratic functions with the standard form of a quadratic function. Now, before I go into this particular slide, however, I want to alert you to something. What this textbook calls the standard form is a little bit different from the commonly used or the commonly known standard form of a quadratic function, right? Most of the textbooks and most places, they refer to the standard form of a quadratic function as f of x equals ax squared plus bx plus c. What this book refers to as the standard form is usually called the vertex form of the parabola. All right, the vertex form of the quadratic function. This is called the vertex form. Now, I don't know why this book uses a different name for the vertex form, why they have decided to call the vertex form as the standard form. However, if you have learned elsewhere in a previous course or in a high school course or in another textbook, if the standard form is shown as ax squared plus bx plus c, then let me tell you, this is the most commonly used form of the standard form. But anyway, we will go along with the book, all right, and refer to the a times x minus h whole squared plus k, which is really the vertex form. We'll just go along with the book for the time being, all right. Now this form, the vertex form of the quadratic function, gives us a lot of information about the parabola that goes along with the function. It first tells us, the first thing it will tell us is the location of the vertex of the parabola. All right. It'll also tell us the direction in which the parabola opens. So, all right, so let me just, now mind you, a parabola is a U-shaped graph. Could be opening up or it could be opening down. All right. Now the vertex is the point where the graph changes direction. Okay, in an upturned graph, the vertex is the place where the graph comes down, all right, comes down and then changes direction and then moves up, all right. In a downturned graph, the vertex is a point where the graph reaches a peak and then drops, all right. So that's where the vertex is, and this form, the vertex form of the equation, tells us where the vertex is located, and how the information in this form that tells us about the vertex are these two values, h and k. H and k are the coordinates of the vertex form. So the vertex will be located at whatever h and k values are, whether it's an upturned graph or a downturned graph. All right. The a, all right, the value and the sign of a will tell us the direction of the graph. That means whether the graph is going to open up or whether it's going to open down. If a is a positive value, all right, if a is a positive value, then the graph opens up. If a is a negative value, then the graph opens down. And also the absolute value of a will determine whether the graph is going to be a narrow graph or a wide graph. So let's just read through the slide here, the verbiage on the slide. It says the graph of f is a parabola whose vertex is the point h comma k, right? So h comma k, these two values, all right, and h, the form, we have to somehow remember the form, all right? You will not be given the form on tests and exams, so please make sure you know it, know the form, and it's not difficult. It's a times x minus within the brackets and then plus k. Now when we were talking about the transformations of graph in chapter 1, I think I had kind of gone over this. All right, so h comma k tells us about the location of the vertex. The parabola is symmetric with respect to the line x equals h. So what that means is the symmetry, the parabola is a mirror image of each other about the line h. All right, so h is the x coordinate of the vertex. All right, so it's going to be symmetric about the line x equals h, the vertical line drawn through h. All right, and then it says if a is greater than 0, that means if a is a positive value, the parabola opens upward. It's going to be an upturned U. If a is a negative value, then it's going to be a downturned graph. All right, so this information we are going to use in subsequent examples, subsequent presentations, to be able to draw a graph, all right, of a parabola, fairly accurate graph of a parabola. So here we talk about graphing quadratic functions with equations in what the book calls the standard form, but is really the vertex form. All right, so we have the vertex form given here. I'm trying to open up the pointer. All right, so we have the vertex form given here, a times x minus h whole squared plus k, a not being 0. All right, if a is 0, then this whole expression will become a 0 and it will no longer be a quadratic function. All right, so that's why they are very particular to mention that a is not equal to 0. And for the rest of the slide and the next slide, they lay out the steps one by one to go about drawing a graph by picking up critical information, relevant information from this form of the function. So let's go through it, and then of course we'll work through an example. Number one, determine whether the parabola opens upward or downward. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. So in order to determine which direction the parabola opens, we have to look at the sign that goes with a. If a is positive, then it opens upward. If a is negative, it opens downward. Number two, determine the vertex of the parabola. And the vertex of the parabola is determined by h and k. These h comma k are the coordinates of the vertex, h being the x coordinate and k being the y coordinate. All right. And again, you have to know the form. It's x minus h, and h is whatever comes after the minus. So we have to, and later on we'll work through an exercise on that. When we look at a quadratic function in this form, we have to rewrite it in exactly this form. It has to be rewritten as x minus, and then whatever h is, whether it's minus or plus, that's going to be the value of h. And again, like I said, we are going to go through an example of that. All right, and it'll be clear, more clear what I mean. So we determine the vertex of the parabola. So that will give us 1 point on the graph. Next, we have to figure out the x-intercepts. That means where the parabola is going to cross the x-axis, where it's going to intersect the x-axis. So find any x-intercepts by solving f of x equal to 0. So the way we find the x-intercepts is by taking the function, making it equal to 0, because at the x-intercept, the y is equal to 0. Right? At the x-intercept, the y value is always going to be 0. Any point the x-intercept, excuse me, is going to have a y value equal to 0. So what we do is we will take the function, we will make it equal to 0 and solve for x. The function's real zeros are the x-intercepts. All right. And in later sections, we are going to talk about real zeros. But for now, just understand that real zeros mean that the point of intersection at the x-axis is a real number. All right, that's what it means by real zeros. To go on to the next few steps in the next slide, it says, in step 4, find the y-intercept by computing f of 0. Again, at the y-intercept is the place where the graph crosses the y-axis. And the any point on the y-axis will have an x value of 0. All right, so f of 0. So essentially you are evaluating the function by plugging in 0 for x, and whatever value you get after plugging in 0 is going to be your y value. So the y-intercept is going to be written as 0, comma, whatever value you get after evaluating the function with x equal to 0. And finally, it says in the last step, you're ready to draw the graph. You plot the intercepts, the x and y intercepts. You plot the vertex, and maybe another couple of additional points if needed. But I think 3 points are quite adequate actually 4 points, almost 5 points. It could be, it's 2 x-intercepts, a y-intercept, and a vertex. All right, so 4 points and any additional points. Connect these points with a smooth curve, which is a smooth U-shaped curve, whether it's an upturned or a downturned based on the sign that goes with A. All right, so we'll talk a little more on the how to find the x and y intercepts, and also we will talk about how to convert, how to get an equation in the form from where you can extract the vertex coordinates, the A value, and all that. All right. Here's an example of the quadratic function in, it's a standard form, but it's really the vertex form, and I'll just keep saying vertex form if you don't mind. So graph the quadratic function f of x equals negative x minus whole squared plus 4. So they go step by step showing how to graph the uh, parabola by just looking at this form of the equation. All right, so let me let me write the generic form of this, of the quadratic function. Okay, if you remember, it's a times x minus h whole squared plus k. All right, so the first step had said determine how the parabola opens. All right, so what tells us the direction in which the parabola opens? This, the sign of A. So what is A in this example that's given to us? What is the value of A? A here, we don't see a number outside the bracket, right? We don't see a number here, and when we don't see a number, that means it's 1, right? 1 becomes invisible in multiplication. So it's minus, but that's really means minus 1, correct? So the sign of A, so I'm going to write here the values of the different variables in the form. So A is negative 1, and because A is negative, therefore we know the parabola is going to open down. All right, it's going to be a downturned graph because A is less than 0, A equals negative 1. So we've taken care of that. We have taken care of the direction in which the parabola opens. Now we will look into figuring out the coordinates of the vertex. All right, so the vertex is the point where the graph changes the direction. Okay, so let's get minus x minus 1 whole squared plus 4. Let me align this example to the generic form. So we will have A is negative 1, correct? A is negative 1. We figured that out. Then x, and then we have the minus. Minus has to be visible. And then after minus comes a 1, all right? And that is going to be the value of h. Okay, it's going to be the value of h plus 4, which is going to be the value of k. All right, so k is whatever comes after the plus sign outside the bracket on the right hand side. K is whatever comes after the plus sign. Okay, so we got our values for h and k. It's 1 comma 4, right? So the vertex h comma k is 1 comma 4. So let's see what they've written here. They said the vertex is at h comma k, right? H comma k, that's because h equals 1, and we saw, okay, we aligned the example with the algebraic form, the generic form of the quadratic function, and then we saw that h was 1 and k was 4. the parabola has its vertex at 1, 4. Going on to the next step, the next slide, it says the next step is to find the x-intercepts by solving f of x equal to 0. So what this means is, just keep in mind that I'm going to just draw the x and y. Okay, so here are our x and y coordinates. So when we talk about x-intercepts, that means it's a point. It can be any point on the x-axis, right? It's any point on the x-axis, the point where the graph will intersect maybe the x-axis, and any point on the x-axis will have a y value of 0, right? It will always have a y value of 0, and we have to find the x value. Can be anything from negative infinity to positive infinity, but the y value will be equal to 0. So that's why it says f of x, which is the same as y, equal to 0. So we are going to make y equal to 0, all right, and solve for x. So that's what they've done here. So they have taken the equation in this form. You have learned how to solve equations, quadratic equations in the ax squared plus bx plus c form, whether using the quadratic formula or whether using any other method, factoring method, and so on. But let's see how they've done here, because this equation, this function, is not in the ax squared plus bx plus c form. So they've taken minus x minus 1 whole squared plus 4. They've made f of x, the other side, equal to 0, and we are solving for x. So we have to have the x by itself on one side. Everything else goes over to the other side. So first thing is they move the plus 4 over to the other side, so it becomes minus 4. Whenever we switch the terms to the other side, the sign changes, right? So plus 4 on the other side is minus 4, and that's why they have a minus 4 here. And what are we left with on the right hand side? It's minus x minus 1 whole squared. Now we have to get rid of the negative. So what do we do to get rid of the negative? We divide both sides by -1, or you can also multiply both sides by -1. In any case, whatever you do on one side, you have to do exactly the same thing to the other side to keep the equation the same, to keep the equation balanced. So minus 4 equals negative x minus whole squared. If we divide both sides by negative, we get a positive 4 equals x minus 1 whole squared. And then what do? We take the square root of both sides, correct? So here we end up taking to get rid of the squared, all right, we take the square roots of both sides, and we end up with x minus 1 equals plus 2 and minus 2. So whenever we take the square root, it has to be a plus minus. All right, plus minus square root over 4. So now we have x minus 1 equals plus minus 2. So we have to take x minus 1, make it equal to 2. So although we have collapsed the plus minus, all right, as one number with 2, it's actually x minus 1 equals positive 2 and x minus 1 equals negative 2. So it's two different equations. All right, so x minus 1 equals 2. So move the minus 1 over to the other side, and we get 2 plus 1, 3. And x minus 1 equals negative 2, therefore x equals negative 1. So the two values of x are 3 and negative 1. However, the coordinates of the x-intercepts, you have to put the 0 also in there for y. So it's going to be negative 1, comma 0, and positive 3, comma 0. Okay, so maybe the, and I'm going to just, because maybe the, on the left hand side of the x-axis, -1 is here, +3 is here. So let's see, now we have to find the y-intercept. Okay, so we've now found 3 points. We've found h comma k, we've found the two x-intercepts, -1 comma 0 and 3 comma 0. And what did we find for h comma k? I think it was 1 comma 4, if I remember right. 1 comma 4, that's the vertex. This is the first x-intercept, this is the other x-intercept, and now let's see what the y-intercept is in the next slide. All right, so to find the y-intercept, okay, what we do is we plug in 0 into x in this expression and evaluate it. All right, because if I again draw the x and y coordinates, we said that any point on the x-axis will have a y coordinate of 0. Likewise, any point on the y-axis, okay, any point on the y-axis will have an x coordinate of 0, right? I'm sorry, yes, we'll have an x coordinate of 0. Okay, so because we are, x is here, right? So we do not shift left or right from the point of intersection, right? So x is going to be 0 and then y is going to have a non-zero value. So that's why since we know the value of the x coordinate of the y-intercept, which is always going to be 0, just plug in 0 for x and solve for and evaluate this expression. So they plugged in 0 for x and we got -0 minus 1 whole squared plus 4. So minus 1 squared. All right, so minus 1 squared, the minus is also squared, is a +1. So -1. All right, so this evaluates to +1. Always when you square a negative number, you should get a positive number. All right, negative number squared is always a positive number. So, and then minus times +1 is -1. So that's how they got the -1 plus 4. So 4 minus 1 is 3. So the y-intercept is at 0, 3. All right, so next slide we will go into plotting the actual graph. Now here, let's go over the final result of all the steps that we went through previously. So the final step is step 5, graphing the parabola. So we know based on the sign of A that it's going to open downward. We found our x-intercepts. There were two places where the graph is going to intersect the x-axis. One is at -1, 0. Again, to remind you, the y coordinates on the x-axis, all right, for any point on the x-axis, the y coordinate must be a 0. So we have -1, 0 located here and 3, 0 located on the right hand side. And then the y-intercept, the point where the graph is going to cross, the y-intercept is 0, 3. And finally, we have to locate the vertex, 1, 4, 1, 4. All right. So once we plot the points, all we need to do is connect the points with a smooth curve. It has to be a U-shaped graph, not a V-shaped graph, because V-shaped graphs are for absolute value functions. This is quadratic. It has to be U-shaped and it has to be a smooth curve. And then once we connect these points, we just extend the graph to either end. Okay. Okay, I think that's about it about drawing the graph. Maybe we will go through another example, another complete example of drawing a quadratic graph uh, in another podcast. So in the next few slides, we will talk about um, quadratic functions in a different form from what we just learned. The form that we just learned, which is commonly called the vertex form elsewhere, would give us information about the vertex of the graph right away. All right, we could just look at the form, we could pick up the values of h and k, and we would know where the vertex was located, or at what point the vertex would be located. Similarly, we could look at the value of a and tell whether it would be a upward open graph or downward open graph and so on. Now we will look at this form of the equation of the function, again commonly referred to as the standard form, which is ax squared plus bx plus c. So f of x, which represents y in a function, equals ax squared plus bx plus c, right? So from just by looking at this equation, at this form of the function, we will not be able to tell the coordinates of the vertex. We may be able to tell the whether it's going to open up or open down, and we'll talk about that pretty soon, but we won't be able to figure out the vertex right away just by looking at the form as is. So what we do is we have to use a formula. We have to do some more work to get the vertex coordinates. All right. So the formula to identify the vertex x comma y, or h comma k, so to speak. The vertex coordinates are uniquely referred to as h comma k, all right, where h represents the x coordinate and y represents, or k represents, the y coordinate, all right. So to find h, to find the value of h, we have to use this formula, minus b over 2a. This will give you the h coordinate. All right, let me take out my pen. So just this part, minus b over 2a, is the h coordinate. To find the k, all right, to find k, what we need to do is we need to find f of, all right, f of minus b over 2a. In other words, whatever we found here, the value of h, we have to plug in that value into the function, all right, into the function equation, evaluate, and that would be the value of k. So it's f of minus b over 2a. So first we have to calculate, first we have to find the h coordinate. First we have to do the calculation of minus b over 2a, and then we have to take that value, plug it into the function, okay, evaluate it, and that would be our k coordinate. So the x coordinate is minus b over 2a, The y coordinate is found by substituting the x coordinate, which is in this case is h, into the parabola's equation and evaluating the function at this value. All right, this value, whatever we get for h. All right, again, mind you, x coordinate is h in the case of vertex and the y coordinate is k in the case of vertex. Just a way of uniquely identifying the coordinates of the vertex of a parabola. Now let's go into graphing, the graphing steps of a quadratic function when it's given to us in this form, f of x equals ax squared plus bx plus c. All right. Now the steps remain the same pretty much, except that we are using different formulas to find the vertex. All right. But we still have to first figure out whether the graph is going to open up or down. Then we have to find the vertex, the coordinates of the vertex. Then we have to find we have to find the x-intercepts, we have to find the y-intercepts, and then finally we can go and draw the graph. So those steps remain the same, except that some of the formulas are going to be different, because here we do not have an h comma k visible in the form. We have to calculate the h comma k using the formula. So let's go through the first step. It says determine whether the parabola opens upward or downward. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. Now that remains the same as in the vertex form of the function. All right, so here, all right, we look at a, which is the coefficient of the first term in a quadratic function. A is the coefficient that goes with x squared, and x squared should be the first term. All right, the squared term would be the first term. So if in an equation, if a function is given to you not properly ordered from the highest exponent to the lowest exponent, we first have to put it in proper order. Otherwise we'll end up picking the wrong values for a, b, and c, and that's very important because we have to use a, b, and c in our equations. All right, to get the graph coordinates. So here we just look at a, which is the coefficient of the first term, and see whether it's negative or positive. If it's positive, if a is greater than 0, we know the graph will open up. If it is less than 0, or in other words, if it is a negative value, it's going to open down. Next step is to determine the vertex of the parabola. Again, we use the formula minus b over 2a, and f of minus b over 2a that we just learned in the previous slide to find h comma k. Then we need to find any x-intercepts by solving f of x equal to 0. So what we are going to do is this whole expression has to be made equal to 0. So again, remember at the x-intercept, the y-coordinates are always 0 for any point on the x-coordinate. All right, so we just have to replace f of x with a 0 and solve this equation for x. If we can use the factoring method, we can do that. If it cannot be factored, we have to find some other way of solving it using the quadratic equation formula or the square root method or whatever it may be. All right. So find any x-intercepts by solving f of x equals 0. The real solutions of ax squared plus bx plus c equal to 0 are the x-intercepts. And then in step 4, we are going to find the y-intercept by plugging in 0 for x, because any point on the y-axis will have an x value of 0, right? Any point on the y-axis will have an x coordinate of 0. So all we do is we plug in 0 into the function and evaluate the expression, the function. So because f of 0 equals c, the constant term in the function's equation, all right, the y-intercept is c and the parabola passes through 0, comma c. Now this is only true if it is in that form, all right, in that standard form of ax squared plus bx plus c, all right. And I will explain with an example what this means. And then number 5 is, of course, to draw the graph, plot the intercepts, the vertex. We plot those points, and then we connect those points and extend the ends of the graph, all right, indefinitely. Now let's look at an example of graphing a quadratic function in the form of ax squared plus bx plus c. So the quadratic function given to us, whose graph we have to draw, is f of x equals minus x squared plus 4x plus 1. Now we are going to go through the steps one by one that we learned previously, starting from first determining whether the graph opens up or down. Now in order to do that, in order to complete the first step, we have to look at the sign that goes with a, which is the coefficient of the first term of a properly ordered function, of a properly ordered quadratic function. So we have to look at the values. We have to pick the values of a, b, and c correctly in this case. What I'm going to do is I'm going to write the form, all right, the standard form ax squared plus bx plus c right below this, so it's easy for us to pick the values correctly by aligning the example with the form. So let me see if I can get my pen out. So what's the generic form is ax squared plus bx plus c. All right, so here we see that this minus 1, all right, so when a number is not visible, when the coefficient value is not visible, that means it's negative 1. So negative x squared is the same as negative 1, and that's what the value of a is. All right, so a equals negative 1. All right, b, what is the value of b? So let's see what the coefficient of the second term is. In this case, b is 4. All right, so I'm going to write b equals 4. We do need the value of b in the next step, so let's write that down here anyway. And then finally we need c, which is 1. All right, so this c aligns to 1, so c equals 1. So we got all our values now. We may not be we may not need to use c, but let's go through the steps and then we know which ones we are using and which ones we are not. A, definitely we are in step 1 because the sign of A tells us whether the graph is going to open up or down, and we see that we have a negative sign. A is a negative value, therefore we know the parabola opens downward. All right, A is less than 0. Now let's go to the vertex, go to finding the vertex, which is the second step. Again, h comma k is not visible in this form, so what we have to do is we have to use the equation for h and k in order to find the coordinates of the vertex. So we said that h was equal to h, which represents the x coordinate, is minus b over 2a, and K is going to be f of whatever minus b over 2a evaluates to, which would be h. So I'm just going to write it as f of h. All right. So here they've done the calculation. Okay, the x coordinate of the vertex is, which is h, all right, equals minus b over 2a. So you have to plug in the value of b, which we just found out, which we just extracted from the function. So b is 4. So we are going to substitute b with a 4. All right, now negative sign is outside of whatever value b is. All right, so negative and then 4 over 2 times negative 1. Remember, a is negative 1. So that's why it's very important for you to extract the values of a, b, and c correctly. All right, otherwise we will not get our answers right if we'll be inputting wrong values. All right. So minus, let me plug in the values, although they've done that in the next step, but let me write that. It's minus, and then let me erase this and write it a little better. Okay, bear with me. Okay, for some reason I'm not able to erase that, so I'll just keep going. All right, so it's minus, b has a value of 4, so I'm going to say minus. All right, so minus 4 over 2 times negative 1. All right, so we will have negative 4. All right, this negative, all right, I'm applying to 4. So negative 4 divided by 2 times negative 1 is negative 2, which is 2. So in our vertex of h comma k, we found that h is going to have a value of 2. To find the, and that's what they got here. All right, you see they worked it out here. That matches with what we found just now, writing it down. So k, and they will continue this in the next slide, but I might as well do it over here anyway. K is f of whatever minus b over 2a evaluated to. All right, so I'm going to write it as f of h, all right, because that's what the value of h is. So f of h equals k, correct? So what we have to do is f of h as a value of 2, we have to plug in this 2 into minus x squared plus 4x plus 1. So let's replace the x variables in this function with 2. So it's going to be minus, again, please use your brackets when you are working these things. So minus 2 squared plus 4 times 2 plus 1. So we will have minus, again, first evaluate the exponent and then apply the negative when the negative is outside the brackets. All right, so 2 squared is 4, so we'll have negative 4 plus 4 times 2 is 8 plus 1, correct? So minus 4 plus 8 is positive 4, and 4 plus 1 is 5, and that would be the value of k. So I'm going to go to the next slide and see if that's what they have found. All right, in the next slide. So this is a continuation of step 2. We found up to the value of h, the h coordinate, which corresponds to the x coordinate of the vertex, and I did work through the steps to find the k, but the Pearson continues the step 2 in this slide. So the coordinates of the vertex are again minus b over 2a comma f of minus b over 2a. We did the calculation of minus b over 2a, which represents our h. Okay, and this would represent k, correct? So we already found that h, which corresponds to the x coordinate of the vertex, was 2. So all we have to do is plug in 2 into the function of minus x squared plus 4x plus 1. And that's exactly what they did. They replaced the x with 2 in the equation, and they also got a value of 5, which is what we also got when we worked it out. All right, so the coordinates of the vertex are 2 comma 5. So that completes step 2. Now we'll go into step 3, which is about finding the x-intercept. Now we are at step 3, where we have to find the x-intercepts. How do we find the x-intercepts? We take the function make f of x equal to 0. Again, to remind you, at the x-axis, the y-coordinates are always equal to 0. All right, so we are trying to find that when y is 0, when f of x is 0, what would be the corresponding values of x in this function. So they've replaced f of x with 0, all right, which represents the y coordinate. So 0 equals minus x squared plus 4x plus 1. Now the easiest way to solve this quadratic equation would be to use the factoring method. However, as we can see that this is not factorable. All right, we cannot find values, or we cannot find factors of 1 which will add up to the uh, to the to the middle term, all right, or rather to the coefficient of the middle term, which is 4. There are no factors of 1 which will add up to the coefficient of the second term. That's how we start the factoring process of quadratic equations, correct? So this is not possible using the factoring method, so we are going to have to use the quadratic equation. So again, you have to remember the quadratic equation, the formula for the quadratic equation is what I mean. We will not be providing a formula sheet for this course, unfortunately. So the formula, the quadratic equation formula, is x equals negative b plus minus square root over b squared minus 4ac. The whole thing is in the numerator, minus b plus minus square root over b squared minus 4ac divided by 2a. So please make sure that you run the line of division under the entire expression minus b plus, because sometimes I see students just dividing the square root over b squared minus 4ac over 2a. All right, remember minus b is a part of the numerator. Good. So all we have to do, once you got the formula right, all you have to do is plug in the values correctly. There's A in the formula, there's B in the formula, and there's C in the formula. So we will need to identify these values correctly from our form, which we already did in a previous slide, but let me do that again. And then plug them in correctly, evaluate correctly using the order of operations the right way, and then completing the computation. Right, so let me just one more time identify A, B, and C from this form. So the form is, if you remember, ax squared plus bx plus c. All right, and so we saw that A represents the coefficient, sign and everything included. A represents the coefficient of the first term. All right, so A equals, where do I write this? Let's see, A equals -1. B is whatever the coefficient is of the second term. All right, so B equals +4 and C is a constant term, so C equals 1. C equals 1. All right, so now that we have extracted the values of A, B, and C from our form, we can just plug in those values into our formula. Now let me pull up my pointer. So the first is minus B, correct? So it's minus whatever B is, 4. B is +4, so we have -4. Then plus minus, so plus minus. Then we have the radical sign, the square root sign. Then it says B squared. So that means 4 squared. Again, please use your brackets, all right, around the entire B. Again, it's just to help you stay on the right track and get the answer correct, all right? Because if this were a negative, if B were a negative value and you forgot to put the brackets around the -4, all right, then what would happen is you would just square 4 and forget about the negative sign. So that shouldn't happen, and that's the reason I insist that please use your brackets. All right, it's a much cleaner way to work in math. So 4 squared and then -4AC. So -4, A is -1. Again, as you see, they've used brackets around -1, and C is 1 as well, but +1. So again, they've used brackets. So please follow that practice. Divided by 2 times A. So 2 times whatever value A is, -1, and that's what they've plugged in. All right. Now we are going into simplifying this, into evaluating this. So we have -4, then plus minus. So first we will try to combine what is inside the radical sign, right? So 4 squared is a 16. Then -4 minus 1 is +4. So -4 times -1 is +4 times +1 is +4, right? So this becomes a +4. Why? Because we have multiplied -4 with -1, making it a +4, and then the next value is a +1. So +4 times 1 is a +4. Divided by 2 times -1 is -2, right? So let's continue simplifying this. So 16 plus 4 makes it 20. So now they have -4 plus minus square root over 20 divided by -2. So x is -4 plus square root over 20 divided by -2. And they've used the calculator here, so we get -0.2 now. And then the other value of x is -4 minus square root over 20 divided by -2, which is positive 4.2. All right. So just keep in mind, this plus minus means there are 2 values of x. And also, please remember that a quadratic equation will always have 2 values for x. Okay, so make sure that you are writing, all right, that you are finding 2 values of x when you are solving a quadratic equation. So here, one value of x is -0.2 and the other value of x is +4.2. So this plus minus itself means that we have collapsed it into one expression, the plus minus, but actually it refers to 2 operations, one with a plus, the other with a minus. So that's how we get 2 different values of x. The x-intercepts are therefore minus 0.2, the y equals 0. Like I said, at the x-axis, all y values are 0, and the other one is 4.2, comma 0. Okay, so we have found our x-intercepts using the quadratic formula here. Then in step 4, we find the y-intercept. That means the place, the point where the graph is going to intersect across the y-axis. And at the y-axis, x is always 0. All right, all points on the y-axis will have an x-coordinate of 0. So all we do is plug in 0 for x and evaluate the expression. So f of 0 equals negative. Wherever there's an x, we replace the x's with a 0. So negative 0 squared, again, no matter what the value you're plugging in, please use your brackets to start with. So minus 0 squared plus 4 times 0 plus 1 equal to 1. All right, now in a couple of slides back, they said that when the quadratic function is in the form ax squared plus bx plus c, all right, let me write that down here. When our form is f of x equals ax squared plus bx plus c, if you plug in 0 for x, the answer will always be whatever the value of the c is. Okay, it'll always be whatever the value of the c is. Why so? Because if you plug in 0 into the x's in the first two terms, these will become 0, 0 multiplied, or any value multiplied by 0 is always going to be 0. All right, so you will always be left with the last term, which is c, which is the constant term. There's no x variable visible in the last term of the quadratic function. So that's what they meant. So the y-intercept is 0, comma 1. All right, because the constant term here was 1. So now we'll go into step 5 and graph the function using the different points, coordinates that we found. All right, so now that we know how to draw the graph of a quadratic function fairly easily by obtaining some information from the different forms of a quadratic function, we will go into analyzing the nature of the graph of a quadratic function. Now, one thing we know about the quadratic function is that its graph has a U shape, right? It is either an upturned U or a downturned U, and the graph of a quadratic function is called a parabola. All right. The U shape of the graph suggests that either there is a minimum, a low point in the graph, so the graph decreases. Okay, the graph is on a descending path up to a certain point, all right, and then it starts rising. Likewise, in a downturn graph, we see from left to right, the graph starts increasing. It keeps increasing up to a certain point, and then it changes direction and drops. And that point where the change of direction happens is called the vertex, and the location of the vertex is denoted by its coordinates h, comma k. So the graph of a quadratic function will have what is called a minimum point, all right, the lowest point in the graph, a minimum point, or if it's a downturn graph, it'll have a maximum point, all right, it'll have a maximum point. So that's what now we are going into study, all right. So it says here, consider the function, the quadratic function, ax squared plus bx plus c. If a is greater than 0, then f has a minimum that occurs at x equals negative b over 2a. Remember, this is the formula we use to find the h coordinate of the vertex, all right, which corresponds to the x value of the point, the vertex point. And a greater than 0 means that the graph is an upturned graph. All right, it opens up, therefore it'll have a minimum point. Graphs that open up, only graphs that open up will have a minimum point. All right, graphs that open up will not have a maximum point. The maximum point is on graphs which are downturned, which open down. So it says if a is less than 0, that means if a is a negative value, we've learned that before, then f has a maximum point, a peak at x equals negative b over 2a. Again, this is the formula for to find the h coordinate of the vertex when the function is in the standard form of ax squared plus bx plus c. All right. Now, the minimum value is f of minus b over 2a. So, again, let me open up my pen. This minus b over 2a is the h value, and f of minus b over 2a, if you remember from the past slides, is what k is. So the minimum value, if a is greater than 0, let me erase this line. The minimum value if a is greater than 0, I'm trying to get my pointer up, is k. All right, is k, and we know how to find k. If we know what h is, then we can just plug in h into the function and we will get our k value. All right, if a is less than 0, then it'll have a maximum point where at x equals negative b over 2a, and the maximum value, which means the k value, the y value, k corresponds to the y value, correct, of the vertex, is going to be at f of negative b over a. So you may be asked two questions about the minimum and maximum of a quadratic function. The first would be, again, I'm trying to pull up my pen here, so bear with me. All right, so one would be where the minimum or the maximum is located. And that's going to be h, the value of h. All right, so it's going to say at what point, when the question is phrased as at what point does the minimum or the maximum occur. And I'm going to write that here because that's another way the question can be phrased. At what point is minimum or maximum located? You have to say at x equals whatever the h value is of the vertex. So there you are giving just the x coordinate of the vertex. The other question that can be asked is what is the minimum or the maximum value? And to answer this question, you will need to give the k value. All right, answer would be whatever the k value is. All right, so in that case you have to write what the k value is, y equals, whatever this value is, or k equals. All right. Now this slide reiterates what we just discussed in the previous slide about the two questions that can be associated with the minimum and maximum of a quadratic function. The first one is about the location of the minimum or maximum value. So when they ask you a question like, at what point is the maximum or the minimum value located, then you give the information of the x coordinate of the vertex, which is equal to h, that minus b over 2a. If the question is, what is the minimum or the maximum value, then you will give the y coordinate of the vertex, which is f of minus b over 2a, which also is represented by k, right? The vertex, we said, is uniquely referred with the coordinates h comma k, and k represents the y coordinate, which is f of minus b over 2a, and h is x equals minus b over 2a. So when they ask you where is it located, where is the minimum or the maximum value located, please do not give the y value, please do, or the k value. What they're asking you is for the x coordinate of the vertex. All right, so keep that in mind. Otherwise, on a question like that, if you mix it up, then you will lose points. All right, so please keep that distinction as to when to provide the location and when to provide what the exact value of the minimum or maximum point is. Let's go through an example on answering a question about the minimum or maximum. It says, consider the quadratic function f of x equals 4x squared minus 6x plus 1000. Determine without graphing whether the function has a minimum value or a maximum value. So to determine that, whether it has a minimum value or a maximum value, we should try to find out whether the graph opens up or whether the graph opens down, correct? If the graph opens up, then it has a minimum value. If the graph opens down, and let me use my pen here. So if the graph opens up, then it has a minimum value. If the graph opens down, then it has a maximum, a peak point. All right, it has a peak point, and as what's called a nadir point, N-A-D-I-R, nadir is the lowest point in the. So how do we figure out whether the graph opens up or down? By looking at the a value. All right, so in ax squared, this is in the form ax squared plus bx plus c, correct? So if we look at the sign associated with the a value, then we will know whether it opens up or whether it opens down. So let's take a look at what the a value is. A value is 4, right? Positive 4. A equals 4, which is greater than 0. Therefore, the graph will open up. So if the graph opens up, then it will have a low point. From left to right, it drops up to a certain point, which is called the vertex, and then it rises. So the solution they've given here is just what we discussed. A equals 4, which is greater than 0. The function has a minimum value. Now we are going to answer some more questions on the same function, 4x squared minus 16x plus 1000. So we already saw previously that this graph will have an upturned graph, a graph opening up. A is positive, is greater than 0, is 4. Therefore, it'll open up, and therefore it'll also have a low point, a minimum point. It'll not have a maximum point, it'll have a minimum point. So the question here is find the minimum or maximum value and determine where it occurs. So they're asking you two questions, two pieces of information here. When it says find the minimum or maximum, that means they are asking you what is the minimum or maximum, as the case may be. And then they say and determine where it occurs. Where it occurs means they're asking you for the location. And location we discussed. We said if they ask you for the location, tell them the x coordinate or the h value of the vertex. All right. And if they ask you what is the minimum or maximum, then you're going to give them the y value, the y coordinate, the y value or the k value, which we use interchangeably. X, when we talk about the vertex, x and h are used interchangeably. All right. So how do we go about that? We first have to find, in order to answer these two questions, we need to know what the h and k values are. All right. So we have h comma k, which are the coordinates of the vertex. To find the h, the formula is minus b over 2a. So let's see what our what a, b, and c values are of this function. So a, as we see, is 4. All right. B equals negative 16. All right, now that is very important. I'm going to again write the form. Just a second. I'm going to write the ax squared plus bx plus c form and just show you how to align the a, b, and c values. So we have ax squared plus bx. So the form has a plus in it. Plus bx plus 1000. Correct? So a we know is 4. C is going to be 1000. All right, plus, all right, plus 1000. However, b, all right, the b is negative 16. Why so? Because the form has a plus. So we have to extract a plus to fit the function into the form. We have to extract a plus from the minus. So when we extract a plus from the minus, the b value is negative 16, right? So plus times minus would be a minus, right, over here. So when we extract the plus, the b should have a negative to it, right? So now that we have the values of a equals 4, b equals negative 16, and c equals 1000, don't think we'll need the c for this exercise, but we can plug in the values for b and a and find what h is. All right. So minus is with the formula, and then b is negative 16. Again, use your brackets. Negative 16 over 2 times a is 4. So we will have minus times minus 16 is positive 16, 2 times 4 is 8, so 16 divided by 8 is a 2, and that is what our h value or the x coordinate of the vertex is. The x coordinate of the vertex is 2. And that is where the minimum or maximum, whatever it may be, is located. We said this is an upturned graph, therefore it'll have a minimum point, and it will be located at x equals 2, right? That's where the location is. We just give the x value. When we go to answer the question, what is the minimum or the maximum, then we have to give the k value. And how do we find the k value? By evaluating the function at f of h, or f of minus b over 2a. All right, f of h. Okay, so what is h in this case? F of 2, correct? H we found is 2. So f of 2, just plug in 2 into the function. We have 4x squared, so 4 times 2 squared, and then minus 16 times 2 plus 1000, plus 1000. Okay, so first you have to calculate the exponent. So 2 squared is 4, and 4 times 4 is 16. All right, so this is 16, and then minus 16 times 2, the next term is minus 32 plus 1000. Sorry, 1000. Right, so we have negative 16 plus 1000, which is going to be 984. So that's going to be the y coordinate, also called k value of the function, all right, of the vertex rather. So let's see how they have solved it on the slide. They have first picked the values or specified the values of a, b, and c. They got the value of b as negative 16, and then they plugged it in, all right, in the to find the k value, they plugged it in f of 2, just like we did here. So 4 times 2 squared minus 16 times 2 plus 1000 equals 16 minus 32 plus 1000. So the minimum value of f is 984, and the value occurs at x equals 2. So that's how you have to answer the question. We now go into answering another question on the quadratic function, which is about the domain and range, and without graphing. So we are given the same function. Consider the quadratic function f of x equals 4x squared minus 16x plus 1000. Identify the function's domain and range without graphing. So we know that the graph is an upturned graph, and it has a low point, okay, and at both ends the graph extends indefinitely. All right, indefinitely means all the way to infinity. It'll keep going and going. It'll stretch on either side of the x-axis as far as we can go. All right, so if this, well, let's see, let's say this is the x-axis. All right, this is the x-axis. Then the graph will the graph will extend on both sides, both ends, indefinitely. All right, now we found that the vertex, actually this is not the right place for the vertex, so I'm going to kind of erase my x and y coordinates. And well, it's not a properly scaled graph anyway, but Let's just try to make it a little more realistic. Okay, let's say this is. So we saw from the previous exercise, from the from the question when we were asked to find where the minimum and the maximum are located, we saw that the vertex of the graph is located at 2, 984. That means the x coordinate is 2, and let's say this point on the y-axis is 984. All right, now it's not a properly scaled graph, so just let's assume that that's where 984 on the y-axis is positive 984. So since the graph extends indefinitely on both ends, we say the domain means all the x values, all the possible x values that can be input into this function extends from negative infinity to positive infinity. X can take on any value which is a real number. However, what are the range values that can be the output that can come out from this function? All right. So the range, think about it. What is the lowest point of this function? All right. The lowest point, the vertex, the y value. Range means the y values, correct? Range represents. Okay, range represents the y values of the function. So the lowest y value on this graph, okay, the lowest y value is at 984. The graph does not descend, no y value, the graph does not have a point anywhere below 984 on the y axis, right? So 984 is the lowest point in the graph, and then any other point on the graph is greater than 984, right? It's going up. It's going up the y-axis. We do not have a point on the graph that's below 984. All right, so a graph that has a minimum point, all right, that's the lowest y value, which will be the range of the function. All right, so that's why they say the range of the function is 984 comma infinity. So to extend beyond that, it can extend to any y value, all right, above 984, but it's just that we do not see any y values lower than or less than 984. So the way we write it is the range of the function is 984, and you note there's a square bracket, which means 984 is included in the range, and then any value greater than 984 going all the way to positive infinity. All right. Now this kind of lays down a three-part strategy of solving problems involving maximum and maximizing or minimizing quadratic functions. But I think rather than read this, I'm going to read it anyway, read it out. But I think it'll be more meaningful when we go on to the next slide where we use these strategies to work through a problem. So it says here, number 1, read the problem carefully and decide which quantity is to be maximized or minimized. Use the conditions of the problem to express the quantity as a function in one variable, and then rewrite the function in the form f of x equals ax squared plus bx plus c. Now, although they say here rewrite the function in this form, you can still use the vertex form, that is a times x minus h whole squared plus k form, to answer questions on minimizing and maximizing quadratic functions. All right, so we'll go through that, but let's go on to the next slide, which talk about an example. Okay, in step 4, it says find the coordinates of the vertex by using the formula minus b over 2a to get the x coordinate. All right, if a is greater than 0, f has a minimum at x equals negative b over 2a, which means it's an upturned graph, and this minimum value is f of negative b over 2a. If a is greater than 0, f has a maximum at x equals negative b over 2a. The maximum value is f over negative b over 2a, and then answer the question posed in the problem. The example given here is a word problem. All right, so it says, let's read through it. It says you have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Okay, so I'm going to just draw a picture to help myself understand what they are talking about. So here we are talking about a rectangle. All right, a rectangle, and we don't know the dimensions of the rectangle. All right, but it says you have 120 feet of fencing to enclose a rectangular area. So in a rectangle, by the property of rectangles, all right, the opposite sides are always of the same length. All right, the opposite sides of the same length. So if this side is x, the other opposite side should also be x. If there's a y, if let's say that's the width, if the width is y, then the opposite width is also going to be a y. All right, and when we talk about fencing, all right, fencing is done around the plot, right? When you put up a fence, you don't fill the area inside the plot with your fencing material. No, you put up the fence all around. All right, you put up the fence all around your property. All right, or the plot, let's say. Okay, this is the fence that goes around the plot, so to speak, right? So let me erase. Oops. Just a second. All right, so that means the fencing material, all right, the fencing material of 120 feet will go around the plot, which is also called the perimeter of the rectangle. That means perimeter represents the length of the length all around the rectangle. All right, so this y plus x plus y plus x. All right, so that means 2 times x plus 2 times y. That's the formula for the perimeter of any rectangle. So perimeter formula is 2 times x, the length of its width and length, all uh, the measure of its length and width all around the rectangle is what I mean. 2x plus 2y, that is the perimeter, the measure of the rectangle all around it. Okay, so 2x plus 2y, that's the perimeter. And then it says find the dimensions of the rectangle. Basically, it wants us to find x, the values of x and y, but that which maximize the enclosed area. So which maximizes the enclosed area. So the area is what the measure um, of the enclosed portion of the rectangle. So all this represents the area. Okay, so the measure of the plot inside the boundaries of the rectangle is the area, and we know that area of a rectangle goes by this formula: x times y. All right, it's length times width, x times y, or length times width, okay, whichever you may designate as the length or width. So step one, they said first decide what must be maximized or minimized. So it says here in the question itself, we need to maximize the enclosed area, and then it also says what is the maximum area. All right, so we must maximize the area of a rectangle. Well, let's go on to the next slide to do complete step 2 and 3 and 4. Here we go into the next step to express this quantity as a function in one variable, as a single variable, because we represented the area as well as the perimeter area in two variables, length times width, which was x times y. Area equals x times y. We have to represent everything in terms of one variable. Same thing we did with the perimeter. It says we have 120 feet of fencing, so the perimeter of the rectangle is 120. So 2x plus 2y, which represents the perimeter, is 120. So the amount of fencing material that we have of 120 feet is the perimeter of the rectangle. All right, so that's why they have 2x plus 2y equals to what is called the perimeter. And since the fence is going to cover the perimeter of the rectangle, we put 120 here. So to get everything in terms of one variable, we are solving this equation for y. So we take 2x plus 2y equals 120 and write it in terms of one variable. That means y by itself on one side. We are solving for y. So y by itself on one side, everything over to the other side. So we start with 2x plus 2y equals 120. All right, so we are solving for y. That means we have to isolate the y. All right, we move the 2x over to the other side. So when we move 2x, when we move any term to the other side, we have to change its sign. So plus 2x becomes minus 2x on the other side. So we end up with 120 minus 2x. And what are we left with? 2y. All right, we have 2y equals 120 minus 2x. Now we have to solve for y. So we have to get rid of this 2, the 2 multiplicative of y. So what do? We divide both sides by 2. All right, so 2 and 2 divide. Okay, 2 and 2 divide, so we have 1y now. So y equals 120 minus 2x divided by 2. So which ends up, when we simplify this, it becomes 60 minus x. So remember, this has a common denominator. So when you are simplifying, you have to distribute the common denominator and then simplify. So it's 120 divided by 2 minus 2x divided by 2. So if you are using a common denominator, when you simplify, make sure you are distributing the denominator to both the terms in the numerator. So I'm writing it out as 120 divided by 2 minus 2x divided by 2. And what happens then? 120 divided by 2 is 60, and 2x 2 and 2 divide. 2x divided by 2 is minus x. So we have, this is 60, all right? So 60 minus x is what they got here, all right? So now y is represented in terms of the x variable. The value of y is 60 minus x. So let's write that down here. Y equals 60 minus x, right? That's an expression to evaluate y in terms of x. Now we are going to use the formula for the area to solve for, to come up with an equation rather. All right. So area equals x times y. We want everything in a single term. So we are going to replace y with 60 minus x in the formula for the area. In x times y, we are going to substitute 60 minus x in place of y and come up with an expression which is in terms of just the x variable. So see what they did here. They replaced 60 minus x into y again. Please use your brackets because 60 minus x is for y, right? And then they distributed x to everything within the bracket. So we have 60x, x times 60, and x times minus x is minus x squared. So we have 60x minus x squared. So A is, again, put the equation or the function in proper order of exponents from ascending from highest to lowest. So the one with the term with the highest exponent is placed first, is the first term, minus x squared plus 60x. All right. Now let's go on to the next slide to see the next part of this problem. Okay, so we are continuing our example on maximizing the area. We have worked through two steps previously and we obtained a function of the area, okay, a of x, meaning the area, the function is that of area which takes as an input one of the dimensions of the rectangle, and the function is minus x squared plus 60x. Now this is in the standard form, which is ax squared plus bx plus c. All right, and I'm going to try to fit this into the standard form to obtain the values of a and b and c, which we will need for the subsequent steps, right? As we can see, this is a quadratic function, so it will have a parabola as its graph, and we have to figure out whether the parabola is going to open up or whether it's going to open down. So first, let's try to fit this into the form of f of x, right? So I'm going to write the form f of x equals ax squared plus bx plus c, right? That's the form. So now we can identify our a, b's, and c's. So what is a? A equals, a is going to be -1, correct? A is whatever the coefficient of the first term is. We don't see a visible number, we see the negative sign. So when it's just the negative, that means it's -1. So A has a value of -1. What about B? B equals 60. B is the coefficient of the second term. So 60 is what B is. So B equals 60. What about C? All right, we don't see a visible C over here, which means that C is equal to 0. All right, that's why we don't see the C, because it's when the value of c is plus 0, it's as good as not having the c in the function. But the form still has, if we were to fit the function, if we were to fit the given function into to the given form, it would be minus x squared plus 60x plus 0, right? So in step 4, we have to go into finding the vertex values of the, at least the x coordinate of the vertex values. So since a is a negative value, okay, because a is negative, we know this is going to be a downturned graph, downturned parabola. So it's going to have a maximum point, right? A downturn graph goes up to a certain point and then changes direction and drops. So it has a maximum point. It has what's called a maxima, right? And then we have to find the coordinates of this vertex. Now, all right, that's our next task, to find the coordinates of the vertex. We always have to work with the, or start with finding the x coordinate, also represented as h value of the vertex. All right, so the formula for h is minus b over 2a. All right, minus b over 2a. All we need to do is plug in the value of b and a into the formula. So minus is a part of the formula, all right? So minus, and then b is 60, so we write 60 for b, and then 2, and then a is negative 1. Surround the negative 1 in brackets. All right, so you know we are multiplying and not subtracting. And then what I'm going to do is I'm just going to rewrite this up here. Okay, I'm going to apply this negative sign to the 60. So negative 60 over 2 times negative 1 is negative 2. A negative negative divides, becomes positive, so 60 divided by 2 is positive 30, and that's the x value, that's the x coordinate, the location where the y value will be at its peak. All right, now it says here a is less than 0, so the function has a maximum at this value at x equals 30. That's the location. This means that the area A of x of a rectangle with perimeter 120 feet is a maximum when one of the rectangle's dimensions x is 30 feet. Right? That's what it means in terms of this particular application, word problem application. So we are going to complete answering the question of the word problem, okay, in the final step here. It says, what was the word problem? All right, let's go through that. You have 120 feet of fencing to enclose a rectangular area. So they had given us the length of the material, fencing material available to us. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? That's what we have to find. All right, and as well as the dimensions of the rectangle. So we said that the rectangle, a rectangle had dimensions x, let's say here, this was x, and then opposite sides having the same value, they are equal to each other. So we had x, x, and y, y, and the perimeter 2x plus 2y, which is the formula for the perimeter of any rectangle, is the same as the length of the material for fencing, which is 120, right? Now from this equation, we found that y, when we solve for y to get everything get an equation in one variable of x, we got the y expression as 60 minus x. If you remember, you can just look back a few slides and you'll see we simplified. We solved for y, and then after simplification we came up with this expression for y equals 60 minus x, and then we plugged this 60 minus x into the formula for the area, which is a equals x times y, and we derived a function for the area a of x equals minus x squared plus 60x, right? That's what we had got. So this is just to bring back all the information to this slide. All right, so we know in the previous slide we found through finding minus b over 2a that x, the point, the x coordinate where the maximum, where the area is the maximum, is x equals 30, correct? So if x equals 30, then going back to this formula, y equals 60 minus x, I'm going to plug in 30 into x into y equals, what was the formula for y in terms of x? 60 minus x, so I'm going to plug in 30. I'm going to plug in 30 for x, and y is also going to be 30, correct? So this, rather than being a rectangle, is going to be a square. Remember, a square has this equal sides, 4 equal sides, so to speak, right? So if x equals y, then this is really a square. So anyway, x equals 30, y equals 30. And the question is, what is the maximum area? What is the maximum area? All right. So for that, we have to use this formula, this function here. We need to plug in 30 for x, because we know at x equals 30, we will get the maximum area, correct? So that's what they have done here. A of x equals, they've taken the function a of x equals minus x squared plus 60x, they've plugged in 30 for x, and let me do the same here. Let me write it down, that way you can see how they got to the final answer. So a of 30 equals negative 30, again use your brackets, that's very important, all right, minus, this minus stays outside the bracket. X has a value of positive 30, and that's what goes inside, that's what goes inside the brackets and gets squared. All right, and then plus 60 times 30. Now I see over here they didn't show this x being substituted by 30. They should have, it must be a mistake. All right, so you have minus 30 squared, let me write that, minus 30 squared plus 60 times 30. All right, so let's evaluate this. So 30 squared, we first do the squaring, all right? Whatever is inside the bracket needs to be completed first. So 30 squared is 900, and then there's a minus outside the bracket, so it's going to be minus 900 plus 60 times 30. 60 times 30, 6 3s are 18, so 1800 minus 900 plus 1800 is 900 square units. All right, so that's how they got this 900. Now it is a little bit confusing because they made an error in the slide. They should have shown the substitution of 30 into the x next to the 60. All right, that's why I worked it out here. It's 60 times 30, so minus 900 plus 1800, which comes from 60 times 30. And then when you do the subtraction, equals 900. So the maximum area is 900 square feet.